All right, you guys, let's go ahead and get started here with the lesson 5.7, solving similar triangles. In this case, guys, we are going to be taking a look at a few theorems as well as solving triangles in this case to prove their similarity. Just a few things, guys, before we get started. There's a difference between something considered similar and something being congruent. And something is similar in this case, they're going to be similar by ratios. And that's being it's proportionate to itself. Whereas if you have something that's congruent, it's exactly the same. So we're focused on similarity today. All right. So two triangles are similar if and only if, in this case, guys, all angles are equal, or at least two of them. If you have two angles in this case that are equal to each other within two triangles, then those triangles are similar, and you have corresponding sides, or corresponding sides have the same ratio in this case. And we're going to go ahead and see a few of these problems. Once again, this symbol here would once again represent similarity. This one would be representing congruency. So starting off, guys, with our first theorem, we do have angle, and in this case it states that if two triangles have two equal angles, then the triangles are similar. And once again, in this case, guys, it's just based on whether we have the same angle measurements. In this case, we actually have two. So we have 72, which is corresponding to the other one, 35 as well, which in this case would also mean that the third one is also similar. So you'll actually only need two angles to determine similarity. All right, here is the next one. Next one in this case talks about SAS, or side angle side. And in this case, it says that if two sides have the same ratio and one angle is congruent, then the triangles are similar. Now, in this case, guys, it does have to go in the format where you have a side that has the same ratio as the other one corresponding side, then you have an angle, then you have another corresponding side. So, for example, if we take a look at the triangle ABC and triangle XYZ, we want to go ahead and determine whether this here is true. So, obviously, they do have the same angle. So angle, in this case, A and angle X are congruent. They're the same. They're equal to each other. So we actually want to go ahead and see if corresponding sides in this case, for example, AB, let me change the color for that. If AB in this case is going to be corresponding to XY, and if AC in this case is going to be corresponding to XZ. So in this case, if I have a 15:10 ratio being AB and XY, I could actually simplify that to 3:2. So that would be our ratio. If I do the same thing on the next one, which is 21:14, and we simplify this here, it's also a 3:2 ratio. So because they do have the same ratio on each side, doesn't mean they're congruent. It does prove similarity. Once again, same ratio proves similarity. Now let's go ahead and take a look at this last theorem, which in this case is side, side, side. And in this case, it says if two triangles have the same ratio on all three sides, then the triangles are similar. So same as the previous one, the only thing is that now we have to prove that all the sides are going to be, all corresponding sides are, in this case, the same or have the same ratio. So in this case, once again, this is triangle ABC and this is triangle XYZ. So in this case, we have AB, which would be corresponding to XY. We have BC corresponding to YZ. And we have in this case AC corresponding to XZ. So let's go ahead and check the ratios for those in this case. Starting off with AB and XY. So that starting off is a 4:5 ratio. Okay, so we can't simplify that, so that stays. Then we move on to the purple, which is the YZ and the BC. So that is 6 and 7.5, not 4, 7.5. And in this case, guys, we could actually manipulate this one here to prove that it's going to be 4/5. Let's say in this case that we multiply both of these by 2. And if we multiply that, that's 12 and 15. In this case, we can simplify 12 and 15 by 3 to give us a 4:5 ratio. Once again, same ratio there. Now let's go ahead and check the last one here, which is 8:10. And that is also a 4:5 ratio. Okay, so that is showing similarity here. So these are similar. Similar by side. Okay, so let's go ahead and check in this case, guys, with an example here. And this is actually we have parallel lines, 2 parallel lines cut by 2 transversals. In this case, they're giving us a bit of information here. They're telling us that line L and line M are parallel lines. Parallel lines in this case means that they won't be connecting and never actually. And they're giving us a bit more information. It says vertical angles are congruent. So measurement of BAC or BCA is congruent to measurement DCE. Now, when they're giving you measurements in this case, in this format where you have 3 different angles in this case, the middle angle is the one that's important. So they're telling in this case that the vertical angle BCA and angle DCE are congruent because they are vertical angles. So this is congruent to this angle because both of those are vertical angles. Vertical angles are congruent. Next thing they're telling us is that alternate interior angles measurement CDE is congruent to measurement CBA. So CDE is congruent to CBA. Once again, we're looking at the middle angle. So here they're telling us that this angle here is congruent to this one because of the alternate interior angles. And in this case, guys, just based off that, we could actually say that these two are similar by angle because we do have 2 consecutive angles congruent to each other. And because we're actually able to prove similarity there, we could actually find the missing side. So they do have a missing side in this case, which is CE. And our goal in this case is to actually find CE. All right, so we want to go ahead and find that measurement there. Now, in order for us to do this here, we do have to build up ratios or actually build up proportions. There's 2 ways you can do it. You can build proportions by same angles or by corresponding sides. I usually like to do it with corresponding sides, but there's different ways you can do it. So in this case, I do want to go ahead and get started with, in this case, side, let's use a different color, BC here is actually corresponding to CD. So I will be putting BC over CD equal to the corresponding side in this case of AC with CE. All right, so this is AC over CE. So in this case, we do know the values of those sides. So for example, BC has a measurement of 5. CD has a measurement of 3 equal to AC in this case has a measurement of 4. And CE is actually what we're trying to find. So in this case, once again, this is building proportions. So in order for us to solve a proportion, we actually have to cross multiply. So in this case, that would give me 5 times x is a 5x equal to 3 times 4 is 12. If I want to solve for x here, divided by 5, x in this case equals 12 over 5. So that's actually not x, but it's actually CE. So that's our answer. And that's actually what we're going to go ahead and be doing in the cons for today. You will be solving for missing sides, and then you